Right. Hello and welcome to today's webinar brought to you by RotaChrom, the leading specialist in industrial scale CPC technology. So today we'll be talking about CPC Simulator. It is the proprietary tool designed by RotaChrom to ease the lives of the CPC users to make the workflow even easier. So we'll be mainly talking about CPC Simulator and a little bit about the CPC technique as well. So if you want to know more details about the CPC techniques, centrifugal partition chromatography technique, like how to develop solvent systems for that, method development, and so on, you can always go to our website, and then you can visit our homepage and find the related webinars for that. So we have a number of webinars for you to check out there. So I am Shan Gomati. I am the business development specialist in your area, and assisted by Maria, which is my counterpart based in Hungary. So we will go into the presentation now. A little bit about RotaChrom. So RotaChrom has been around for more than a decade now. It is the innovative services for client success. So that's the motto of RotaChrom. So it has in-house feasibility study, a study run by RotaChrom Lab with the partners material that is to evaluate the possible outcomes and also to prove the successful purification of the target compound or compound of interest. So we collaborate with renowned partners, establishing lasting relationship with research institutes and companies, expanding and diversifying our reach. So we also have other proprietary tools other than CPC Simulator, an array of tools designed to assist our clients on every step of the process. So from estimating the costs of purchase and operation, like the TCO calculator, total cost of operation calculator, and also to simulating and visualizing actual chromatographic separation. So we have the method development and optimization team as well. So we can make tailor-made methods that are developed and adapted for individual compounds of interest, and also purification requirements based on the field CPC scope assessment form. And optional production scale study, so with RotaChrom's expert team to optimize future operational parameters and also enhance potential yield and profit. So we have expert team with years of experience, CPC users in our lab, so they can help you to find a good method, a good solvent system for your target compound. And we also have exclusive solutions like know-how transfer agreements and also exclusive tailor-made solutions. So we understand that every sample, it is different. So most of them, you may need tailor-made solution and tailor-made designs as well. So we have several sites. So we have our lab in Hungary, in Dabarj, Hungary, for lab and method development purpose. And in Kecskemét, we have our production site. In Denver, US, we have our service and application support. In Kuala Lumpur, Malaysia, we have the application support, which is me. So a little bit about basics of the CPC. So CPC separation, it occurs between two immiscible phases. So two biphasic phases, you can make biphasic phases by combining 2 or 3 or even 4 solvents. Combine them together in a different ratio, so it will give you a biphasic immiscible liquid phases. So one of the phase, the stationary phase, it is immobilized inside the rotor by a strong centrifugal force. And the mobile phase, containing the sample to be purified, it is fed under pressure into the rotor and pumped through the stationary phase in the form of tiny droplets. So your stationary phase, it'll be maintained inside the column by a strong centrifugal force. And then your mobile phase will be pumped through the CPC column by an external pump. So the CPC, the chromatographic column, in CPC. It is called the rotor or the column. And it is cells interconnected in series by ducts attached to a larger rotor. So the solvents, it will propagate from one cell to another cell. So it has simple mechanism, and this is the most important parameter in the CPC separation, which is the partition coefficient, KD. So how does it work? You have two immersible liquid phases. And if you decide to use the upper phase as a stationary, lower phase as mobile phase, it is called the ascending mode. In descending mode, you have the upper phase stationary, lower phase mobile, it is descending mode. So let's say in ascending mode, your mobile phase will be coming from the bottom, doing the separation to the bottom by forming tiny droplets, equilibrating on the top, going out to the top. So the mobile phase is ascending to the top, ascending mode. And if you have the mobile phase coming from the top, doing the separation through the stationary phase on the top, equilibrate at the bottom, go out through the bottom, the mobile phase descending to the bottom. So it is called the descending mode. So you have two modes, ascending mode and descending mode. So for each CPC run, you can choose between ascending mode and descending mode. In some advanced CPC cases, you can use ascending mode and descending mode in a same run. So that's for advanced CPC technique. So most important parameter in CPC separation is the KD value. So for a particular solvent system, for a particular biphasic solvent system at a fixed temperature, the KD value is concentration of the compound in the upper phase over concentration of the compound in the lower phase, or concentration of the compound in the stationary phase over concentration of the compound in the lower phase. So you have a biphasic solvent system, and then you add in your mixture of compounds here. You shake it, let it equilibrate. So after equilibration, your compounds will be separated according to the KD value in the upper phase and the lower phase. So now you need to measure the KD value. So let's say you are taking equal amount from the upper and the lower, measure them separately inside a HPLC system. So you inject the upper phase, you have your separation. You inject your lower phase, you have your separation, and then you compare the intensity of both of the chromatographs, right? So you compare upper versus lower, stationary versus mobile phase, and you get your KD value. So the smaller the KD value, the faster that it will come out from the CPC column. So let's say for this compound, for the first compound, KD value is 0.33. So it comes out from the column first. And the second compound, KD value equal to 1. Second to come out, and the third to come out is KD value with the highest KD value number. So this is important parameter for you to use inside the CPC simulator, the KD value. So usually we will develop our CPC solvent system by using CPC modeler, the lab scale CPC 250 ml column. So that is in real life. So with the CPC simulator, it is the similarity-based search engine for finding the best solvent system for your compound of interest. And the database, it consists of mostly natural product compounds. So it is the compounds that is in our database, it is natural product heavy. And the simulation of the separated output, it depends on several parameters. And most importantly, the KD value. So you have the simulator and you have the visualizer as well. So in the visualizer, it will give you a chromatogram based on the KD value, based on the input that you have created earlier. So it is a predictive tool according to the parameters set by the user, by you. And it is a visual representation of the in silico separation. So there are some key features inside the CPC simulator. So you can search for your compounds, you can search the database for different solvent systems used, and you have the visualizer. So this gives you access to the database based on the more than 16,000 entries of scientific publications, solvent systems example, compound data, and also in-house research from the past 5 decades of literature reviews. So it is constantly evolving, and RotaChrom has put immense effort in creating this database, and it is constantly being updated as well. So now, probably 16,000 entries, later on, after 2 months, probably 20,000 entries. And this database, it lets you to simulate the purification results of more than 4,000 compounds. So some compounds, it may have few entries based on different CPC solvent systems that it has been found throughout the publication. So the database. So in the database, you can find the compound and some details about the compound like Cas number, molecular formula, molecular weight, and also the solvent system. The solvent system, the ratio, and the KD value in that ratio of solvents. So this is important. And then here, this is the CPC visualization, the tool. So there are some default values when you choose. Later on, I will be going through the demonstration with you. So you can choose between different CPC models, and each model, it has some default values, and you can input the names of your compounds and also the KD value and some other information, and you can have the visual representation of that chromatogram with those particular compound and that particular KD value. So these are some of the required information for you to input. So mainly, you just need to choose the instrument, and you will have different parameters, default settings for that particular volume of CPC. So you need to put in your compound name, the KD value, and some other details. So here we have some example. We have an example, a model representation of mixture of 4 compounds. So dimethyl phthalates and diethyl phthalates, dibutyl and dipropyl phthalates. So in that particular solvent system, it has this KD value. And that simulation tool, it has plotted such chromatogram. And we run that mixture of compound in real life CPC run, we get exact same CPC chromatogram. So it is comparable between the simulated and the actual CPC chromatogram. So I would say this is a very useful tool for you to do it, model it in silico, model it just online. And after that, you can actually do the real, based on that, you can do the real CPC run. So we will go into the demonstration now. So I will be demonstrating you the CPC simulation tool by using these 4 compounds and these 4 KD values. So at this point, this is my reference solvent system. I will stop sharing first. Now I will share my screen. So you can go to our RotaChrom homepage. So from there, you can find our. Okay, so in the homepage, you have different subjects here, different topic. You go to the calculator, you can find the simulator tool here. Calculator, that is the TCO calculator. So you just have to log in. If you are not logged in, you just have to create a simple account. And after that, you will have you will go into the CPC Simulator tool. So in the simulator, as I have mentioned earlier, you have the compounds, simulate CPC run, and the search database. So let's say you go to your compounds, and you have the list of compounds. Say you want to search, let's say you want to search catechin. So you will have different compounds coming up. So you may have your compound, you may not have your compound in the list. Let's say you are working on a different isomers of catechin, or a different compound which is similar to your compound that you have found here. So the compounds here, it doesn't have to be your compound. It can be compound which is similar to that, and you can get the solvent system as a starting point for you to work on your CPC solvent system. So in the compound section, you can find different compounds there. You just have to put in the name of your compound, search, and you can get a list. So if it is not in your list, you can find a compound which is similar to your own compound. And let's go to search. Then let's say I am searching for in. So I have many compounds here, which is related to catechin. So you can find, if it is not in this list, you can find a solvent system which is similar to that compound of yours. So here you have the compound, and you have some details of your compound, which is the Cas number, molecular formula, the weight, the mass, and so on. And here you will have the CPC solvent system used in the publication earlier. So you have the reference here, the ratio, and the KD value. So for this, let's say this is the solvent system, the ratio, and the KD value. And for some compounds, it may have multiple publication, and it may have multiple solvent ratio as well. So you can choose one which is the most effective to your own compound. So sometimes you have a different mixture of different impurities. So it may not work with the first solvent system that you find here, maybe because your compound of interest is similar, it has similar KD with your impurities. So you choose other solvent system here, which can be different, which your KD value can be different from the impurities. So that's why for this compound, we have 4 entries of different solvent system. Then let's go to the simulator. So we have, as I mentioned, different scale, CPC, lab scale, 250 ml, RCPC pilot scale, 2.2 liter, and ICPC industrial scale, 23 liter. So let's say CPC, this is the default parameter, even the volume. And lab CPC, now you can see that the default parameter has changed. So for the lab CPC, the normal volume, it is 250. That volume, you can change it more or less. And the stationary phase retention, usually preferred is above 70%. So let's say you have below 70%. I wouldn't say it is a good good representation of the CPC column, maybe you can increase the stationary phase retention by probably decreasing the flow rate or increasing the rotation speed. So you can set the flow rate here, default is 20, and the mode and the injection volume and so on. So here you have your compounds. So let's say I add 4 different compounds. 4 different compounds, and the first one, let's name it as model 1, second compound. So let's say that's the second compound. And most of the natural product users, we do not know the compound. So it can be an unknown compound. So you do not necessarily have to name all your compounds. You just have to, you can leave it as compound 3 and compound 4. So let's say I just leave it and the KD value. So now you can see for the KD value, it's all 1. And it is all coming out at the same time. So now let's say I put the KD value as 0.11. Here, calculate the KD value 0.29. 3, get 0.72. And export compound 1 point. And I want it to be same mesh proportion. Let's say I'm putting it 5. Okay, then I'm putting it 10. All of them having the same mesh proportion. So all of them 25%. And you can see the chromatogram changing as such. Let's say for the 4th compound, it's not 1.4, it's 10. You can see 4th compound, it has actually shifted a bit. So this is how you play with the KD value and use the visualization tool here. So you can make it bigger or smaller. All right. So let's say I am changing the retention of the stationary phase. So increasing it. You can see that this is not actually a good solvent system. This is not actually a good retention. You can see all of them are co-eluting. So this is not good. And I want to increase the so this can be a better one. And let's say flow rate. I want to decrease the flow rate 10. So in this case, compounds are coming out much more slower. So let's say I want to increase it to 5. Coming out much faster, but you may have some compounds co-eluting together. So in descending mode, let's say I want to change it to ascending mode. So descending mode, compound 1, 2, 3, 4 will be coming out. In descending mode, it is the opposite side of direction, 4, 3, 2, 1. So the order of elution has changed. So you can play around with a lot of things here. Okay, so it's descending mode will be better. For this separation, let's say my injection volume now, I increase it to 100. So, of course, the concentration level here, it will increase as well. So this is the simulator tool. I hope you understand the explanation here so far. So let's move on to the next one. So I increase the concentration level here. It is, okay, so a lot of compounds are co-eluting. Okay, let's go back to the presentation. So features. So it is effective solvent system and purification method development for CPC. So only 2 input data is needed, the partition coefficient KD and also the composition of the crude material. So you do not need to take into consideration of the solvent system when you are actually using the CPC simulator. So purification of performance can be modeled, tested, and optimized. So thousands of compounds can be tested in silico to find future directions, and a library of data from scientific literature available developed by chemists and chemoinformatic experts highly knowledgeable in the chromatography sector. So benefits, it is quick and cost-effective computational test instead of slow, cumbersome, and expensive actual experimentation. So it is a library of extensive, well-researched and evolving data instead of time-consuming literature search. So you do not need to go through tens of actual publications. You can just head on to our CPC simulator and you can find a lot of the details, a lot of the publications inside our simulator. And a precise illusion profile with estimation and prediction-based results to support decision making. So we have different models, the CPC modeler, 250 mil, RCPC, pilot scale, and continuous. So continuous, you use the ascending mode and descending mode in one run. So you have 2 CPC joined together by a controlling system. And it can be done with lab scale, pilot scale, and also industrial scale. So you have the ICPC, 23 liter, and PCPC. This is a full-on production scale with full set of skids. So, summary. The CPC Simulator, it is a simple tool to help our CPC users. It is, I would say, it is a very user-friendly, and it is developed in-house. A lot of effort has been put into that, and it has data library more than 16,000 entries and more than 4,000 compounds. So it saves time and resources. Valuable tool to support decision making, scalability insights, so you can scale it up with your pilot scale and industrial scale in the model. And it is used together with a TCO calculator to validate economic feasibility. So that's the end of my presentation. So we still have a few minutes left. If you have any questions, feel free to ask, or you can type it in the chat box as well.